Good afternoon, and thank you very much, David and Dragan, for inviting me to speak. Yes, I want to speak about collaboration. Oh, it moves on. I'm Director of Product Innovation at XP Solutions, and in the UK we're based in Newbury, and you probably know us better in the UK as Micro Drainage, but worldwide XP Solutions. Just a bit of background about me. I say I'm a mathematician, but I'm also an engineer with CWS, and it quite shocked me to realise that I've been working commercially in engineering and software development design for 35 years. I was Director of Product Management at Wallingford Software, and I know some of you from there. I'm now Director of Product Innovation at XP Solutions, as I say, Micro Drainage. I also want to mention the OpenMI Association. We're there to promote integrated environmental modelling. It's still coming, it's still happening, and I'd just like to give that a plug. I've worked on a lot of projects, partly research projects and partly delivery projects around the world, and yeah, I'm not quite sure what is happening there. And I'm very proud of the software systems that I've worked on, including XP Drainage, which I'm going to speak about, InfoWorks, InfoNet, FloodWorks, XP, and Micro Drainage, WinDesign. These are, yeah, I'm proud of them. So, as we know, water management is a partnership. We know that. I'll get the hang of this in a minute. It's a partnership between a lot of different roles, different jobs. And today I want to concentrate on the collaboration of the partnership between academics, the Centre for Water System, and software manufacturer and suppliers. It doesn't move when you want it to. This is the trouble. Right. And the subject matter, I'm going to concentrate on one product and one project, and the project that highlights this partnership. It's in the field of sustainable rainwater management and drainage, and a lot of us here are involved in drainage. And there's a nice definition from Wikipedia: the natural or artificial removal of surface and subsurface water from an area. Well, that's what drainage used to be about. But as we all know, we're trying to do things a little differently now. And perhaps a very loose and woolly definition would be local use of rainwater for common good. I think it's hard for us to define what green infrastructure, ecosystem, SUDs, LID, WSUD, depending on where you are in the world, you might want to call it any of those. It's pretty hard to define what it is. We know it when we see it. And this project, really, and this product is trying to put some hard numbers on this, trying to better define measures of goodness of what a good sustainable drainage system is these days. What do we want out of drainage? Well, we want to recharge groundwater. We want evapotranspiration to cool down our cities, attractive use of water. We want our green spaces to look good, increase the value, of course, of the sites they're on. Flushing, because we're going to reduce piped water and treatment, and increase biodiversity. And so this changes the way what good sustainable drainage is. It's We want to be able to take account of natural flows on a site, compare pre-development and post-development, make sure that we're getting the same sort of answers. We want to store water, we want to remove pollution right there at source. We don't want to pass it down, no more passing problems downstream. And a treatment trainer approach, that means on the site, spread it out across the site. The old measures, it's got to be affordable, robust, maintainable. Of course, those still apply. We still want that. Moved too soon there. So the product, this is the product plug. Oh, it's moved on. We want to really have to allow people to design and evaluate high quality, really good sustainable drainage treatment trains that perform well. It's worldwide. As I've said, this is happening all around the world, and so any good system these days has to apply everywhere. And hey, we've done it, product's there, first trials begin in a few weeks. So why do we need a research project? Why do we need this collaboration? Well, I think it's I'm just going to go back, it's because of these things. These are so hard for a drainage engineer, a designer to measure. It's so hard for them to say, well, I've succeeded because I've done all these. How much have you done those? Put a number on it. Even these things, these are hard as well. These are really, really hard to measure. So the aim of this project is to, there we are, it worked that time. Oh no, no, I clapped my hands, I think that was the mistake. So a systematic multi-criteria decision support framework for sustainable drainage design. And the point of this is to put numbers, hard numbers, on all those criteria. Now we're well into this, we're 3 years in, time's moving in, we're generating some results, it's going well, but no, we're conscious that we've got to get on, we've got to finish this. It's Joe Fei Chow's NGD, he's here, ask him about it, he can tell you far more about it than I can. His supporters, his supervisors, Dragan, me, Zoran, Netsanet, we're all here as well. So, and it's quantifying green values from good feelings to real hard numbers. A lot of the work's based on previous work that's been done. We're not starting from scratch. We're going to use good things that have already happened. Sorry, wrong way. And the results are that we've come up with a set of performance indicators that I think are real-world performance indicators. They do reflect, oh dear, the things that we want. And this is just a shot, but you get the idea that we're trying to evaluate costs and the benefits of sustainable drainage in a way that people, when they're designing, can pick up those benefits and can say exactly how well they've done. And then we want then to be able to help them to optioneer, to be able to look at alternative designs. In fact, even better, to suggest alternative designs for them. Sorry, I'm dashing around all over by hitting the wrong buttons. So that you can maybe use some permeable paving, some swales, or you can do it a different way with some bioretention and perhaps the ponds. What's the difference? Which one gives a better measure right across all those criteria? And this is what the project is there to do. Our conclusions from the project. It's successful. It's already successful, and it will continue to be so. It's genuine innovative research. The results will be implemented. I say they'll be delivered to hundreds of people. Really, I want them to be delivered to thousands of people. It would be false to say I want that to be hundreds. It definitely thousands. And Joe Fei should get his NGD. This is really, really important. It's important to us as it is to the CWC. It's a genuine partnership, and I think this is the key thing, and why I'm using it as an illustration, between a company, a commercial company, and the CWC. And we share management, we share knowledge, and most important of all, we share creativity. The ideas are coming from both, and that's really good and important, I think. Why was it successful? Well, partly because we did know what we wanted to achieve, but I think it's also important that we were fairly flexible how we got there. It's genuine research. We didn't know how we were going to end up where we want it to be. We've got a delivery route for results, so exploitation was there from the beginning, always the aim. The right candidate, I'm not going to, as the Americans would say, blow smoke up Joe's arse, but yeah, he has a lot of good qualities. So, and here's a quote from Joe. So I think that really says it. I love the idea of new and wild ideas and contrasting that with keeping it real, keeping it practical. So, congratulations, 15 years in, going really well. I'm really looking forward to the next 15 years. I was so glad to hear you say that this is about the future. That's great. So more research, more innovation, yeah, more of the wild ideas as well, and yeah, keep it real. Zoran's smiling, but I know he will keep it real. And delivering results. This is great. The CWC, CWS. I keep calling it the wrong thing. It does deliver. And
It's interesting that given the very limited brief we've been given, we've ended up with 3 very different talks. So probably a good thing. Before I start mine, I was reading something on the way down in the train, which I thought was very useful and quite pertinent for today. It's an FWR newsletter. I'm sure you've all read it, actually, but it says here, for multinational corporations, water-related risks are now designated as the highest probability, greatest impact risk to the survival of their businesses. And then it goes on. Academics rarely act on behalf of the water community as a whole, but focus on their own narrow interests. I suspect actually today brings the lie to that comment. But it's very relevant, isn't it, to make sure that it's pertinent. Okay, so HR Wallingford. I've been there for too many years. David Fortune was a colleague of mine next door, so to speak, when he was with Wallingford Software, as it was. So it's all about the relationship, as I understand it, between HR and this centre at Exeter. And I've taken the view to try and take a general picture about the research we've been doing. So I've tried to look into or summarise aspects associated with the benefits of the liaison and the type of possible options that are available to us, which I think has already been touched upon already by a couple of people. Then I'll touch a little bit more on the particular project that I was leading for 4 years under the STREAM project, which is now, he was in the first year, so he's actually now finished, although still busy writing up. And then I thought it would be useful that you've tried to draw out some lessons with the questions, and I have actually got a few points there, and there's always negatives, but hopefully there are some positives. Okay, so HR Wallingford used to be called Hydraulics Research Station. Our directors of the past thought it would be very useful to change our name to be less academic and get rid of the word hydraulics research and make us HR. It's because we were trying to secure a lot of consultancy work. But nevertheless, we still do an awful lot of research, although the research might be considered to be near market rather than blue sky. Target research areas for HR that are important for the UK, at least, are these. But obviously, there's a wider field when you start talking about Europe. But for us, the key thing is in this relationship is trying to make sure that we maintain a lead technically, not only in the water and floods departments that I'm in, but also the marine and other sides that we have. So we have a lot of relationships with universities, and Exeter is a key one as far as our water and flood sections go. A couple of slides have generally shown already that there are NERCs, EPCIRCs, streams, CASE, KTP, TSB, and so on. For those that are not fully initiated in these matters, it's rather confusing because the consultant can sometimes get involved and can sometimes not and gets partial funding and so on. But they all lead to various opportunities with regards to research. And as long as one understands this minefield or gets to the bottom of it with the assistance of Dragon and so on, it leads to quite a number of opportunities. But to my mind, there are 2 ways to categorize it. One is whether the student is based at your offices or whether the student is based at the university. And they have major differences, in my view, in terms of the pluses and minuses. Funding costs are not insignificant. It depends really on the type of student, whether it's postdoctoral or MSc and so on and so forth. But it can be quite a significant component, and that's not including the staff and management time you have to put into it to make sure it's a success from the company's point of view. And therefore, you know, the research has to be really useful. It has to result in something that that has an income stream associated with it in the long term. So just a few examples then. A few years ago, a young lady was stationed with us on a KTP, looking into real options with uncertainty and climate change. And it introduced the whole thing about optimization techniques dealing with the uncertainty of not knowing whether the climate change models are right, and also the breadth of information that the climate change predicts. And you know, she was a great success, not only in terms of obtaining a PhD, but she also was very suitable material for HR to employ, and is now successfully supervising her own student, who is again a PhD student here under the STREAM project. And this person is following on from the work that she's done, and this is under the STREAM project, and is also based at Wallingford. Other angles, as has already been mentioned, is that there are projects in industry which are so-called research. In the case of artificial neural networks, the UCWA organisation, which fronts the water companies' needs for research, they came to a meeting here actually and were very impressed with some initial work that Dragan gave a 10-minute presentation on, such that they invited people to, it was rather more blue skies than they normally do. They just said, well, what is the opportunity here for this work to be extended to the sewerage industry? And they had a brainstorming session with us before we competed with each other for the work. And in actual fact, in the end of the day, we all decided that we would work together on it, so there was no competition involved. But nevertheless, the project involved Exeter as the principal knowledge unit, shall we call it, supported by industry-aware people to derive this work. And it was regarded, I think, as a very successful project. And basically, artificial neural networks offer real potential for moving modelling into the operations section and forecasting for the sewage industry. So watch this space, basically. Another project, another STREAM project, my student has now completed and is writing up the work. We had the core of a tool looking at risk-based sewage asset management, basically, and we have extended that into producing a tool which I call ADAPT, just to try and find some sort of an acronym. And the whole idea is to try and look at the optimization opportunities for improving a whole catchment of sewage system, to make sure that to see what is the cheapest and the most cost-effective way of meeting objectives in the catchment in terms of performance. And various intelligent techniques were included into the tool that was extended by a chap called Will Sayers. And the tool can either look at things in the way the water companies currently do, largely, which is to look at their network and not the rest of the land space, so to speak, just looking at whether it floods or whether it doesn't flood, whether it spills or doesn't spill. There is the alternative, of course, is looking at the consequence impact of flooding properties. So the tool allows both possibilities. So you can have a simple approach, or if you have values associated with damage to properties or damage to the stream in quasi pounds, shillings and pence terms, one can use that. The methods that ADAPT can apply is it can look at changing conveyance systems to improve past water flows. It can add storage systems. It can look at modifying the runoff. It's called SUDS, but really it's basically how much can you modify your inflows into the network. You know, you have a cost function to that as well. But runtime, clearly, when you have running genetic algorithms and so on, is a really key aspect. And the clever bits are trying to stitch in things like neural networks to act as meta-models to give you very rapid analysis and then retrain them when you've got another solution option. I'm sure you all know about genetic algorithms and crossovers and breeding and all that stuff, probably better than I do. But it's interesting to note that actually you can arrive at surprisingly better solutions than your best guess, at least your initial best guess. And therefore, when you have several options available to you, this, I suspect, is probably a worthwhile way forwards over our engineering ingenuity, although we are pretty good at being able to intuitively, effectively rule out options and rule in others because of a whole range of intangibles. You can't build that tank under that school and so on. Nevertheless, this tool may save an awful lot of money in asset management. And the project that we're involved in is an EU project in which Zoran is involved as well. This is we're modelling a catchment in Oslo, and the project, the EU project, is called Trust, which is moving to the cities of tomorrow. So it's actually the transition is as important as getting there. So the tool also is incorporating a way of evaluating how you get from A to B and how the system performs over that time and your investment profile. A couple of other things that are involved with Exeter University and this department that I'm not involved with, but you can see that again it's in the water area and a significant European project. I'm not going to dwell on it, just to show that actually we've had an extensive amount of work that we have had with this university. And the OpenMI thing that David was pushing, we have created this Fluid Earth platform, which many of the universities, we've got a whole tranche of universities involved in doing this OpenMI stuff. Again, I am not involved with it, but nevertheless it's received various awards and so on for this work. And finally, I would just want to put a slant in a slightly different way, in that HR does its own research, and it works not only with academics to draw in information, but it also develops its own tools and skills. But this one, Hammer, which is looking very exciting from the point of view of use, is that there's a lot of noise in the oceans these days, not just the US subs, and their secret ways, but also all this pile driving going on for these wind farms and so on. It's pretty important to find out what the impact is on a whole range of marine species. And we're progressing this, and it's not with this department, but it's with Exeter again. So, lessons. Relationships, I think that was stressed. Get to know the heads of departments and the supervising academics themselves of your students. You need to know each other, you need to know about the drivers. This thing about timing, for instance, literature reviews underpin the research work and the direction in which the academic, shall we call it, necessity that's behind any PhD takes a lot of time. So if you intend to have a deliverable as part of your PhD student, which is a sort of 3 or 4 year term, and you want an output within 6 months, you probably have to think again. Exeter has got a range of particularly useful skills for the water industry, but it's useful to know what their skills are. The other thing is students. They come and go, but they're pretty important to the process. And actually, it's very difficult often for the university to get an appropriate person. But then it's got to be appropriate to the consultancy as well. And often you'll get somebody who may be academically okay, but he may not buy into the whole thing about sewers. He's not interested in a hole in the ground. So it's important from your point of view, as well as the universities, to get an appropriate person. If he's based at the university, with all the, as David was saying, the chances of actually influencing, because life goes by quickly, actually is pretty limited. It's just as difficult for Dragan to keep us informed because he's a busy chap. And often, you know, you'll find that the student that you're supporting is going off in a direction you may not be entirely happy with. So you need to make sure that if it's going to be based here, that the student's work is well aligned with your objectives and expectations. If he's based in your offices, you have to make sure you motivate him, because he is somewhat an outsider. He's a fish that is placed in your office who has to have a relationship at the university and is focused on something which is unique, that is not tied into the rest of the company. So it's pretty important, actually, that you get the appropriate skilled person and his character. Just the final page, and perhaps maybe a digression that you don't want to go on too much on, but everybody has contractual issues, everybody wants contracts, and the contracts section and legal section, whatever it's called here in the university, like any other university, they're entirely taken up with the copyrights associated with developments. And you're meant to sign away your life, and the key thing is they don't seem to understand that if you're putting a lot of money in, your expectation is to use the outputs for your commercial gain. And you'll find in every contract it says that you will be licensed to use it for research purposes only. So there's a big battle to be won every time you have a project, and it really is a pain. But fortunately, and Dragan and David seem to understand this problem, and although they don't have necessarily a lot of leverage with the legal section, they do understand that actually that the reason why we're involved is for commercial reasons, not just pushing forward the bounds of science.
One of these. I am a Senior Product Development Engineer for Hydro International. I'm also a prior employee of the university with the Innovation Department and a PhD student from the Centre for Water Systems, so I have a bit of a biased viewpoint here. But the presentation is about the collaborations we've had with Exeter. I was going to cover a bit about the company, for those of you who aren't aware who Hydro is. Discuss the drivers for the main reasons we work with the universities and why we always seek an academic partner for the longer term projects. Go into a bit more detail about the studentships that we've conducted with the university, and then finish off with the actual benefits that the companies have realised from these partnerships. So the company itself is an equipment and design consultant for urban and wastewater management systems. We've got 5 offices in the, we've got 2 in the UK, we've got 2 in the US, and we have 1 in Ireland. So we're an SME local to the region. Our main office is in Clevedon, and we've got about 130 employees, and the majority are split between the UK offices and the US offices. We've got a turnover last year of approximately 35 million, and we've got a portfolio of around 30 products. Most of them are in-house developed, about 20 of them. Another 10 or so are licensed in and resold through other companies. Here's my product plugs, but I was just going to give you an idea of the kind of systems that we supply. The top line is the wastewater treatment systems. Gritkin and the Headcell are preliminary treatment systems. The Dynasand is a tertiary treatment system. Sludge Screen is a sludge screening system. On the bottom line, we've got some of the stormwater treatment systems. HydroBreak is one of our most popular UK products. It's a self-activating vortex or self-activating passive flow control. Downstream Defender is a sediment interceptor for control of stormwater pollution. Stormblock is a subterranean flow attenuation storage crate system. And the Storm King is a CSO treatment system. We have a lot of collaborations. We work with a lot of different universities, mainly in the same locations that our offices are in. Over the last 10 years or so, we've had a number of US collaborations for independent approval of some of our equipment. We worked with the University of Alabama on a product development effort, and that was with 1 PhD and 2 master's projects. But in the UK, by far our biggest collaborator is the University of Exeter, but we have worked with a few other universities in the last decade or so. Our main drivers for collaboration are mainly access to knowledge. We're always trying to get the inside track. We want to know about arising thinking, arising technology, and arising legislation that might drive the markets. Our internal development projects are mainly short-term. So anything less than 18 months, we will have an internal function only. Anything longer than that, we want to reduce our risks. So we will almost always have an academic partner or another industrial partner. And that reduces the risks through access to funding, accelerated learning, so we can adopt all of the research that the university has done on a particular subject, process efficiency, any best practice that is already knowledge of the university, and minimise overheads of projects. What I mean by this is the studentship costs are normally a fixed resource or a fixed level. Anything outside the studentship is normally a big ticket equipment item, and it's very easy to predict and make a forecast of project costs around these expenditures. And probably the most important one for the longer term projects is access to a dedicated resource. We always conduct a studentship program because internally we just cannot guarantee, being an SME, that we'll have that person available for a full 3-year project. And the only real way to do that for us, without hiring someone dedicated to do the job, is to do it through a studentship. Our collaboration with the Centre for Water Systems started in 2007 with my KCP and PhD project. We continued on the strength of that in 2011 with another Stream Eng-D and then another in 2012. And I'll come on to talk to those in a bit more detail in a minute. We've also, over that time, run a number of MEng group projects on, over the last 4 years, flow control design, bioretention systems, drainage system monitoring, and filtration media. Those have been a great way for us to get in touch with much wider literature reviews, new technology, and new knowledge. For example, the bioretention system investigation, you can see there on the right-hand side, that's a couple of photos of the students on site taking media samples from the system. They then scanned those in a CT scanner, modelled them, took the geometry, modelled them in CFD, and also performed experimental comparison to then see if they could get a good validation with the model. And the CT scanning and that process is a valuable way for us to gain new knowledge about new processes. And other services we've accessed from the university recently are we've attended some of the funding workshops, which we are now actively progressing and seeking external funding. We've used the Centre for Additive Layer Manufacturing a few times, and we've also rented the compute cluster from Gavin, which is part of the CWS resource pool, for when we've actually been at high capacity with our own facility. I'll just go on to talk about the studentships that we've conducted. As I mentioned, we started a KCP in 2007. This was a KCP with the Innovation Department with a PhD with the Centre for Water Systems. This is my studentship. The objective of this was to further develop our vortex flow control range, create a more flexible system with additional geometric design parameters which allowed a more flexible hydraulic characteristic. We did this by investigating the system using both experimental methods and CFD to derive new design equations with additional geometric parameters. Then we coupled these design rules with optimization algorithms to drive the geometry and hydraulic characteristic towards a given goal. So now we can drive towards a constant flow rate or maximize a flow rate, maximize clearances to prevent blockages, and also optimize on cost. And we can also set a number of constraints around any of those different goals. The final output of the project was actually a spreadsheet which acted as a design tool. This has now been turned into an internal piece of design software, and it will be soon an external type piece of design software. Interestingly, it's also being incorporated into Windows, so that ties up nicely with David's presentation earlier. So real regional collaboration. Following the strength of the KTP and PhD programme, in 2011 we started a Stream Eng-D. This was with Chris Newton as the research engineer. We are looking to provide a tool to increase flood resistance of drainage networks through the strategic positioning of the flow control. So now we have a more flexible device that we can optimise for different objectives. We're looking to develop a tool which gives a catchment-wide design objective, and the reason for this is we don't see this coming across the desk at the moment. It's a very one location, one scenario. We only have the option to address one point of the system, but we could also use it to reduce or solve targets like reducing the number of properties on a DG5 register, especially for retrofitting cases. In 2012 we started another Stream project, this with Shannon, which I'm sure is a familiar face within the department, and he is looking to optimise wastewater treatment systems using joint solutions for CFD-based simulations. Right, it is a bit of a mouthful, but the company's been using CFD a long time to assess different parameters of their systems and make design decisions. What we're looking to do is hook these into an optimization method. Now, the adjoint method is very useful because it reduces the complexity of the optimization routine down to one flow solution and the adjoint, which allows us to determine the gradients of the function directly, or the optimization function directly, rather than have to use a lot of different discrete points to assess the finite differences, or like a GA where you'd have to perform a lot of different design permutations. So it's very useful for something like CFD, where your solution or solving your equations is a very intensive process. The downside is it's much better at finding locals and not so robust at finding global solutions. The main outputs that we've had so far, this is largely from the KTP and the PhD because the others are still in progress, the other studentships are still in progress. We have two new product ranges, both of them around different geometries of optimizable vortex flow controls. This is the Hydrobrake Optim range. We also have another one in development, which wouldn't be possible without the knowledge gained on the project. We've obtained independent approval for these flow control ranges from the BBA and the WRC, and that wouldn't have been possible without the improved design knowledge and increased accuracy of the design equations developed as part of the PhD. We've actually increased our company innovation rate. This is a metric to measure the amount of sales from new products. So we're looking to double this from our 2011 value. I can't say much about the sales because it's confidential numbers, but it's gone a long way to satisfying that objective. And also from the KTP and the PhD, we have two new IP applications which are currently in the process of being published. They're not publicly available yet, but they will be in the future. Other things that have as additional benefits, internal design tools. We've got a number of different spreadsheets and useful tools specifically tailored to regional guidance. A recent one is an attenuation storage tank sizing tool for Singapore around their public utility board guidance. And we've also developed, from the experience of working with Gavin and the CFD cluster here, we've adopted open source CFD codes as our main workhorse in terms of CFD analysis, and we've developed our own in-house cluster, and that is all from just the experience gained with working with the framework here. Also, recruitment of personnel, that's me, so that's quite a good point. And we've done a number of conference papers, about half a dozen, and a few trade shows. And again, we are increasingly confident about accessing other university services, such as the CARM, the Rapid Prototyping Facility, and the renting the cluster as an additional resource. And of course, attending shows like this, or events like this. Thank you.
Well, ladies and gentlemen, we're getting towards the end of the evening, and I just wanted to say a few concluding remarks, really, about working with you. And in a sense, my thunder's been stolen a little bit, in that you've heard from all of our speakers today the various ways that we can work together, which is great, because you're hearing it from the horse's mouth, not from me telling you the sorts of ways that can happen. So Dragon showed this slide early on, and these are the many companies that we are working with, and we did some sums. And I reckon as a university we probably have thousands of projects a year working with businesses, both locally, nationally, internationally, and something like £30 million worth of research projects on the books that we could obviously link with business partners. I was in CWS, perhaps it's 100 partners, we're talking more hundreds of partners and maybe scores of projects on the go. So it's something that we are very, very, very serious about, both as a university and as a research centre. And so here's my big long list of different ways of working together, and hopefully by now, from what we've heard, you will recognise some of these things as potential ways of working together. So there, of course, there is the standard way of working together, and that is via our students. I think it was Dan who mentioned that he and his company, Hydro, are working with our fourth-year students in a design project, which is quite an unusual thing to do. But it is possible to work with our students on a design problem that can have industrial application. Of course, there's the potential for industrial placements for our students. That's another opportunity to work together. And it can be at undergraduate level, or it can be at postgraduate MSc level as well. So MSc projects is another great way to do some work, and I think we heard about some of those literature reviews that could be done as MSc projects. And then, of course, you will be looking at our graduates as potential employees, and indeed some of our postgraduates as potential employees. Not picking on Dan again, but there's a good example. He's a good example. Then going the level down, PhDs. We have many PhD students, many of whom are here today, and ND students. And you've already heard about our successful doctoral training centres, STREAM being an industrial doctorate centre, and then our new WISE centre. All of which give potential opportunities for linking with the university, CWS, to do research. There is some difference between a PhD and an ND. An ND tends to be more industrially focused, tends to be that the researcher themselves is more embedded in the company. That's perhaps the way of looking at them. You've heard about KTPs, knowledge transfer partnerships. This is again a government scheme organised by TSB, Technology Strategy Board, for tailoring different length research projects from quite short ones, matters of months, up to a PhD. That's the possible range. Again, the person doing the research is typically based in the company, doing a company-led project. Then the sorts of things that we do in a university as a matter of routine, R&D projects, that's our bread and butter. Dragon mentioned earlier on consultancy. We do consultancy, but we are not in the business of competing with consultants. That's not what we do. But we're very happy to work with consultants to put in joint bids where that's appropriate to us both. We do contract research, where if you have a particular piece of research that you would like doing, you can formally contract us to do it. Then you have we've been talking a little bit about deadlines and when you're going to get deliverables and so on when you've got a PhD. With a contract, you get your deliverable when it's in the contract. So it's a more business-like relationship, perhaps. And then there are the national and European projects. We heard a bit about some of those already. It's very common for us in the university to build teams, and when we put in our research applications, to ask you to help us to build a team to enable us to get funding that allows you as businesses to have an influence about the way the project is going. going down another level or up a level, depending on which way you look at it, there is the possibility for sponsorship. If you find that there is something that really catches your eye, a particular person, a particular technology, a particular interest, we do have the potential for sponsored lectureships and indeed sponsored chairs. And then probably the top of the pile, as it were, will be a strategic relationship, a strategic partnership with the university. The University of Exeter is very keen, as an ambitious university, to develop corporate partnerships. No doubt Robin could talk about the partnerships that we already have. We have a number in train. For example, I think it's, I'm not breaking any confidences to say that we signed a contract relationship with IBM fairly recently. So that's the sort of company the university wants to keep, and we would be very interested in talking to you if you'd like to do that as well. One thing I did hear, I think, coming through the presentations was there's a myriad of different ways of working together. All sorts of different schemes, all sorts of different timescales, all sorts of different relationships. And we do have dedicated support in the university. There is a portal, there is a way in through our research and knowledge transfer specialists who have these sorts of things at their fingertips, who can advise you. If you do have an interest in this, they can advise you the best way to go, the best way to extract funding to help you in your business, the best way to get contact with individual academics in the university. So I think that more or less covers the full spectrum of ways that we can work together in the different funding schemes. I would say, though, if you do have any questions about any of this and you are interested in taking something forward, then do contact myself or Dragon, and that's an obvious way for you to get into the university. So there are contact details. I think you should have those on a piece of paper somewhere in front of you. Phone. I was just looking at that fax. I can't remember the last time I had a fax, actually. But still, I think there is a fax machine somewhere. So where does that leave us? Well, that leaves us pretty much towards the end of the evening. I hope you've enjoyed what you've heard. We have deliberately not stood here to tell you how good we are, because you'll have heard presentations like that. We've stood back and allowed our collaborators to speak on our behalf, and you've heard what they've said. What we would like you to do is, shortly, do go outside and enjoy the refreshments that will be out there, but please do engage a bit with our research. So we didn't present anything today formally from the front here, but you will have noticed outside there are 15 or something like that posters, and each poster's got a person standing there. Please do go along and engage them, enjoy having a chat with them and get to know them and what they're doing a little bit more. So, as it says on the screen, thank you for coming. Refreshments and posters are in the foyer now.